Sorry about that. I'm on call, and of course I had a resident come knocking right when I was in the middle of making a video. So, as I was saying, when we have something that is a compound proposition, something that has two independent claims within it, we have to look at the main operator. In this case, the main operator is the AND. So, let's go back and consider our earlier case of Sam, the dog, and the penguin. So, if somebody were to walk up to you and say that Sam has a dog and Sam has a penguin, and you were to say, cool, that sounds really awesome. Can you show me that this is true? Because that kind of sounds a little bit dodgy. And they call up their friend Sam, and Sam walks over and indeed has a dog and a penguin. That means that the entire proposition, the entire claim that Sam has a dog and a penguin is true. Now let's consider the other cases. Your friend tells you the same thing, Sam has a dog and a penguin. And you're, again, skeptical, so the friend calls up Sam, Sam walks over, and it turns out that Sam only has a dog, and there is no penguin at all in sight. Well, we wouldn't want to say that the proposition that Sam has a dog and a penguin is true, since one of the pieces is actually false. If Sam were to try to say, no, it is the case, it is true that I have a dog and a penguin, and I don't have a penguin, that doesn't make a lot of sense. So in that case, the entire proposition itself is false because one of the pieces isn't actually true at all. And the same goes if the reverse is true, in that Sam walks over and it turns out that Sam does indeed have a penguin, which is kind of weird and probably against the law, but Sam doesn't have a dog, then the proposition that Sam has a dog and a penguin can't be true. Again, it doesn't make sense if one of the pieces is false for the proposition to overall be true. And then if Sam just sitting there and says, what do you mean? I'm allergic to all animals. I don't have any pets. Obviously, the proposition that Sam has a dog and a penguin is going to be false. To summarize, in the cases where it turns out that not both of the pieces are independently true, the truth value is false. For and statements, they are only true if all the pieces, all the components are also actually true. So that's it for ands. There's a few other truth tables that we need to know, though. So let's go over those as well. So let's say that I told you that Sam has a dog or a penguin. So Sam has A or B. Let's do this first. So Sam has a dog or a penguin. As before, since we have two letters over here, we need two letters over here. And we want to go in order. So A comes first because it appears first. Then B comes second because it appears second. As before, we're going to follow our pattern. Our pattern is two T's and two F's. And then for the base column to alternate T's and F's. Again, this gets us all the possible combination of truth values between the two components. And then we bring over these components and slot them in under the letters that match. So the A gets T, T, F, and F. The B gets T, F, T, and F. And now we need to look for the main operator. The main operator in this case is the wedge. So let's use a slightly different example than Sam and penguins and dogs. Let's say that you run into your friend and they're eating some food. Or rather, let's say that you ran into your friend last night, they were eating some food, and then today in class, one of your classmates asks you, hey, what was your friend eating last night? And you respond, either they were having center table or they were having local point. You're not quite sure which one is actually the case, but you're pretty sure that those were their only two options because those are the only two places they tend to eat. Let's just assume that, for the sake of argument, that's the only two places they ever eat. It's a very poor choice on their part, but hey, college, you're allowed to make poor choices. So you say that your friend either ate at center table or they ate at local point. For your claim, the proposition that your friend ate at center table or your friend ate at local point to be true, well, if we were to walk over to your friend later on and ask, hey, where did you eat? And they told us, hey, I ate at center table. Well, the proposition that they ate at center table or local point is true, so long as they ate at least one of those places. If you walked over and they said they ate at local point, that would also be true. If we walk over and they say, yeah, first I ate at local point, and then I decided I wanted more food, so I hiked all the way up to North Campus and decided to eat at center table 2, in that case, it is very true that they either ate at center table or they ate at local point. A little bit odd, again, that they walked all the way there from, say, West Campus, but you're allowed to do that. That said, if we walked over to your friend and we said, hey, where did you eat last night? And they say, Chipotle. Well, obviously our claim is false. The claim that they ate at center table or they ate at local point is false because they didn't do either of those actions at all. In fact, they weren't at center table and they weren't at local point. So when we consider disjunctions or propositions where the main operator is a disjunction, a wedge, a disjunction is true so long as it is the case that at least one of the disjuncts themselves are true. As long as you have at least one T, the entire disjunction is true. If both of the pieces are false, however, the disjunction overall is false. So let's go on and finish up with our truth tables. So we have 2 more to do. Let's go ahead and set it up like this. Again, we're just going to keep it with 2 statements for now. Let's say that I tell you that if something is an A, then it is a B. As before, since we have 2 letters on this side, we have to put 2 letters on this side, an A and a B. And then we put 2 T's and 2 F's. And then we alternate T's and F's for our base column. Then we slot these in under the appropriate letters. And now we have to look at our main operator. The main operator in this case is an arrow. Of the truth tables, this is probably one of the most confusing, but that also means it's going to be the one that we're going to guarantee to have on the exam. So memorize this. Please do memorize it. So let's say that I give you a box. And I also tell you a proposition. Let's say I say something like, if it is a duck, then it is a bird. You open up the box, and inside, let's say that you find a duck, and you find something that is a bird, namely because ducks are birds. Well, in that case, since both of the component pieces are true, it's true. Let's say that I told you that if something is a duck, then it is a reptile. You open up the box, and indeed you find something that is a duck. However, you don't find any reptiles, namely because something being a duck isn't enough to make it a reptile of any sort. In that case, the arrow is false. Most people tend to latch onto both of these examples and can understand why T arrow T is true and why, to a certain extent, T arrow F is false. The next 2, however, tend to be a little bit stickier. I'm just going to brutally pause it and tell you that if something starts with an F, it has to be true. It doesn't really matter what it is, so long as you start with an F, whatever follows must be the case. Or rather, the overall arrow statement itself must be true. For the folks that are wondering why this is the case, I'm going to give you a very brief example. So let's say, and I'm going to use the proofs that we've been using to give this example. So let's say that I told you the following. It is the case that I have an A and a not A at the same time. Let's make that premise 1, and let's say that this was given to you as an assumption. For lines 2 and 3, I break down the A and the not A using the lovely rule of and elimination. And these still get assumption number 1s because they're both coming from assumption 1. Now, using one of the rules that we just learned, let's say that I do, or rather, not yet. Let's do wedge introduction first. Let's say that I introduce a B onto this A using wedge introduction. Still, only have one assumption line number there. Using one of the new rules that we learned, namely disjunctive syllogism, what this allows me to do, using lines 3 in lines 4 in disjunctive syllogism is to get to B. Now, notice that B wasn't anywhere in our original proof at all. Wasn't there in any respect. But given that I started with something that is a contradiction, which should be a very big red flag, this actually shows you that anything follows from a contradiction. And since anything follows from a contradiction, that's one of the ways of considering and thinking about why this line right here can end up being true overall. The next one's a little bit harder to see why it is that F arrow F ends up being true. So I'm just going to have to say, brutally memorize that F arrow F is true. That's the best I got. Let's consider our last truth table, and then I'm going to end this video and start on the next one. So let's say that we have a truth table. It looks like this. And we have A, double arrow B. As before, since we have 2 letters on this side, we need 2 letters on the left side. And we follow our pattern again of 2 T's and 2 F's. Then for the base column, we alternate T's and F's. And then we slot these in under their component pieces. And then we look at our main operator. Our main operator in this case is a biconditional. It's a double arrow. This too is going to be something where I'm going to tell you you just need to brutally memorize this. Double arrows are only true if both of the pieces match. If you have 2 T's, it's true. If you have 2 F's, it's true. Otherwise, it's false. There are some other ways that I could explain this using additional proofs, but I want to kind of save proofs for later for things that actually matter for the concepts you're going to be tested on in this class. You don't technically need to understand the nuanced reasons of why it is the case that it works this way. You kind of just have to memorize that these truth tables, so the biconditional, the conditional, the wedge, the and, the negation, and then just the simple atomic letter, those are the truth tables and the operations you need to memorize, and you need to be able to use when we're analyzing truth tables, whether it's truth tables for propositions, complex propositions, or truth tables for arguments. And those are going to be the next 2 videos.